Hey, it's Lee Halliday, and today we are covering another video on some Suspense, React Suspense. And we've got a little demo app here in Create React app where everything right now is being loaded in Suspense. So we've got our nav up here loading lazily. We've got our pages loading lazily. So if I refresh it, you can see for a sec loading. And we have our fetch request using a custom hook here. Obviously it's lazily because when you ever use fetch, it's asynchronous, so it's being done lazily. But we've written a custom hook to basically be able to use React Suspense to show a loading state for us automatically. So in this video, what we're going to be doing is some CPU intensive calculations. We're going to be simulating this with that Fibonacci example that I never understand because I've never had ever in my career a need for using Fibonacci other than these weird little demos and showing recursion, but that's what we're going to be doing. So we'll be doing some CPU intensive work, and whenever you're doing that, you don't want to sort of clog up the main thread in your browser. So I found a little package called WorkerPool by Joss de Jong. And basically it allows you to perform functions not on the main thread in a browser, but in a worker thread so that it keeps your app snappy. And the great thing about this library is A, it's really easy to use, but B, it gives you a promise that is resolved once the code that you're executing in the worker pool finishes. And that's really important because the way that Suspense works is basically it waits for a promise to resolve. So in this little diagram I created over here, we'll quickly go through it again. Our code starts and it hits our Suspense wrapper. So if we go back to the example of fetch that we did in the previous video, but just to show it again here, we're wrapping Suspense around this little Boston routes component that does some asynchronous work. So if it's already awaiting a promise, it will show the render, but that's obviously not true on the first time because it hasn't yet executed the code that kicks off the promise. So the answer is no on the first loop, and it hits our asynchronous code. Our asynchronous code basically has to determine, do I already have an answer? It has the promise resolved and I can just return the response? Or is it the first render? Meaning, what I need to do is kick off my asynchronous code, throw that promise up so that it can get caught by Suspense, which will render the fallback. And when the promise resolves, save it to the cache so that when it goes through this rendering loop again, it will eventually come down here and be able to show the result. So if you're interested in sort of walking through all of that with the fetch example, check out that video. But just because the worker code is going to be very similar to this, let's take a look at it and it will make a lot more sense as we're modifying it. So in our Boston routes component, the first thing it does is it calls the useFetch Suspense hook that we created, passing in the URL along with some fetch options. And what our hook code does is it takes these inputs and it needs to basically create a cache key out of them. And that's used so that as Suspense renders our code a first time and then a second time once the promise resolves, we need to be able to look up the result of the code we ran so that we can return it rather than kicking off that asynchronous code again. So we grab that using the key value from our cache, and we're just using this little least, whatever this stands for, least recently used cache. And we're reading the key, and if it doesn't exist, we're kicking off this new object here, sort of our default, which will have a status of new and no data yet. So skipping this if statement, which is executed on the second time around, we kick off our promise by calling fetch, passing in our URL and our fetch options. Fetch gives you a first promise, which in our example, we're just auto going to convert it to JSON. And this promise returns another promise that we're putting into a variable. And we're putting it into a variable because we not only want to deal with ourselves when it is resolved, but we want to throw this. And we're throwing it so that if we come back here, throw the promise, it's caught by Suspense, because in JavaScript you can throw anything, not just errors, and you can catch anything as well. So Suspense is specifically looking to catch thrown promises, and it will re-render when it catches it, and because it's awaiting the promise, it will call the fallback. As soon as the promise is resolved, it will re-render again, because it's not waiting the promise, and our asynchronous code will look up in the cache, do I have the answer? This time it will be yes, so first render will be no, and it will finally render the result. So on the second time it is being called, this will be true because when the promise resolved the first time, we updated the value in the cache using immer to change our value to have a status is resolved and data is equal to the data returned by this fetch promise here. Actually, specifically this one here. So, because this is true, the status is now resolved, we can just return the data that we already have, which finally comes back out here, and now we can just render it like we're used to doing in React. So all of that as a review, because the calculations we're going to be doing here are very similar to the fetch example. So let's come to the console and let's add this worker pool. And then whenever that finishes, we'll start up our Create React app again. Okay. So let's close everything. And we're going to be doing this on our calculations page. And the first thing we're going to be doing is importing a component that doesn't exist yet because we're going to create it, called Fibonacci from, whoa. All right. So let's come here and we'll say heavy calculations. That's right. If it's just like you're adding two numbers, this is obviously way overkill. But Fibonacci on some big numbers can take your CPU more than a few seconds to process, so we want to be able to show a loading state as it's doing that calculation. So we're going to be using Suspense to wrap that around our asynchronous code that's going to run here. And with Suspense, we always need a fallback. So we will create a little loading calculation, which let's say it takes in a number. No, just make it simple. Yeah, we'll do it. Okay, so it takes in a number and it will return a div that will say loading Fibonacci for num. Okay. Okay, so Suspense. So when it hasn't, when it's in the loading state, meaning it hasn't finished performing the calculation, the promise hasn't resolved yet, we need to show this fallback here, which will be our loading calculation. And the first one we'll just do will be 10, something that can be done pretty quickly. And inside of Suspense, we will Fibonacci for number 10. All right. So now we actually don't have a Fibonacci component yet, so it's going to be a big failure. So let's go add that. So we'll come here and we'll add Fibonacci. I wish I could spell it. Fibonacci. Okay. So we'll import React from React, which takes in our num. and export default this function. Okay, so we're going to create a custom hook that we haven't defined yet, so it's going to be failing until we do, but we will call it use worker. It's going to be generic, so it's not just for Fibonacci. You could use it for any sort of intensive CPU calculation. And CPU, as opposed to something like a fetch, which isn't really that intensive on your CPU. It's slow because it has to go across the internet and fetch a result from some other server. This is slow because it's calculating a lot of stuff locally on your computer. So use worker will take in two things. It's going to take in the function to call. So we are going to go to the WorkerPool example, and they have a Fibonacci, which is apparently deliberately inefficient. We'll take their word on it. And we will copy this function call and pass it in here. So we're not actually calling this function, right? We're just passing in sort of the reference to this function, the one that can be called eventually on a WorkerPool. And the second thing will be the arguments that we want it to call. So Fibonacci just takes one thing, this n, which is the number to calculate. So we're going to pass it as an array of arguments. Why an array? That's just because this is how the WorkerPool works. You always have to pass over any arguments in an array. So would be the first one, the second argument, depending how many the function takes. So we will pass in this num here. Okay, so I know this is failing, but once we get the answer back here, we can just return a div that says answer Fibonacci for num is, and we'll put this in strong, is data, or we could call this something other than data, result maybe. Okay, so it should be still failing because we haven't created the use worker hook yet. So let's import that. Use worker from use, I always put equals, worker. Okay. So I think this code is pretty much done here. And the reason we took a look at this use fetch response before is because it's basically the same logic as we're going to be using for this use worker. So I'm actually just going to copy the entire thing, create a new file called use worker, paste that in. So we'll change that to use worker. We obviously don't need fetch options, so we'll just call this the args that it's receiving. So as we build our cache key, we can, instead of stringifying the fetch options, we can do the args that are passed in. This stays the same. We're still going to try to look up from the cache using this key we constructed. And if there's nothing there, it means it's the first call, so we're going to default the value to new with a data of null. Okay. So once it's resolved, it will return this here. And now we need to change this code here. Okay, so let's rip out all this is fine, but what we need to import in is WorkerPool from WorkerPool. Okay, so we can get rid of this here, and we'll say WorkerPool, and we'll go back to the example of how to use this thing. So whenever you import it, you first need to ask it to create a pool of workers. So we can just do that up here, like that. And now we can ask our pool to execute a function. It's not URL, is it? It's the function that we passed in. So we'll have the cache key be the name of that function. Okay, so we're executing the Fibonacci function, or any function that's passed in. We're passing the args here. So this returns us a promise. And what we're going to do is when this promise resolves, we are going to update our cache to set the value with the key, and we're using immer to create an immutable copy of the previous value. But we're going to throw this promise. And again, the reason we're throwing is so that Suspense can catch this and it can show the fallback until the promise from the Fibonacci use worker is resolved. So let's come back here and see if it's working. Okay. So it's so fast you can barely see that it's showing the fallback. So why don't we try one that will take longer? And you can have multiple suspense blocks. So as they resolve sort of at different times, they'll show their answer as soon as they have that available to them. So we'll do 42 because I know this takes a few seconds. So you can see it's loading Fibonacci for 42, and finally we have an answer. So we could do another one as well, just to bring the point. We'll do 35. So boom, boom, and then this one will come in as soon as it's ready. So there we go. So this is how you can use Suspense, in this case, to suspend asynchronous code for a CPU-intensive operation. And the way we're doing that is by creating a custom hook called useWorker, which will accept a function to execute. And this function will be executed on a separate worker thread. And when it's called, it will receive the arguments passed in here as the array. So this useWorker, again, it takes the func. We're using the name of that function along with an MD5 of the stringified arguments to create the key. And we're using that to look up our data. If it doesn't exist, we'll initialize it, and etc., what I've covered already. Let's just play around with this for a second. If we come here and we say console.log value, we're going to see 6 calls here. 3 for the first time it's called, and 3 when it's called again when the values have been resolved. So if I come down here, that's exactly what happens. We see our first 3 right away, our second 2, and then finally our third one once that promise has been resolved. And another sort of cool way you can fool around with this, one thing I did realize is that I never actually put this value into the cache. So why don't we just do that? Set the key with the value. Okay. And we'll do that maybe here, because if it's already resolved, there's no point in setting its value in the cache. So this will sort of only happen once on the first time. And then what we'll do is we'll come down here and we will put the cache into a window level property. And we'll call it the worker cache. So why am I doing that? I am doing that so that I can come down here and access this worker cache. And I can call on it keys. So here I can sort of see what keys I have in my cache. And then if I wanted to, I could come here and say worker cache. I want to get that value. So here I'm reading it out from the cache, and I can see that it's got resolved along with 55. Okay, so that I guess aligns with the first one in here. Well, that's the example of how to perform a CPU-intensive operation using this really cool WorkerPool package. And we've packaged everything up in our custom useWorker hook, which will work nicely with promises. And again, the reason it works nicely with promises is because, sorry, not with promise, with suspense, is because it utilizes promises that can be thrown from here, caught by suspense, and displayed the fallback until the promise is resolved, in which case it re-renders this, finds the result this time because it was in the cache, and spits out an answer. All right, that's it. Hope you enjoyed the video. Take care. Bye.